Hello and welcome to another episode of Smoke and Mirrors. My name is Bastien Ray. Apologies for the delay in bringing out another video, but the past month has been absolutely crazy. What you are looking at right now is a demo I created as part of a VR related blog post we wrote together with Oculus and which was published on their developer blog. I've put the link in the description below. I've replaced the VR parts with KidsCan Code's FPS controller for this video. Valve also reached out to the Godot team earlier this year, and as a result I have a brand new setup with an Index VR headset. This has kept me plenty busy improving the OpenVR drivers. I hope to do a short video soon on the Index and some of the OpenVR plugin changes. I started doing polls on my Patreon page to help me choose which tutorials to focus on. This video was chosen by my patrons. If you enjoy my videos or the work I've done with Godot, please consider supporting me by donating a cup of coffee each month. As you create larger and larger levels in your games, you'll find that performance starts to suffer unless you implement strategies to deal with these levels. Dealing with these types of performance issues is a balancing act between your game design and the strategies applied by the game engine to minimize how much geometry is actually rendered. Godot implements a strategy called Frustum culling. The blue cone you see on the screen represents this frustum. Anything inside of this cone is within the bounds of the camera and could potentially be seen by the player. Everything outside of this frustum is hidden to the camera and doesn't need to be rendered. It would be prohibitively expensive to test the entire geometry of an object, so this process is simplified by testing an axis-aligned bounding box or AABB. A simple box that is larger than the object. If part of the box is within the frustum, it's likely the object is visible. The few false positives we get are easily offset to the performance gain. However, the more objects there are in your scene, the more Godot has to check each frame, and eventually the culling process itself becomes a bottleneck. One improvement being considered for Godot 4 is to group objects together and check their combined bounding box. When layering this into layers, we can quickly and effectively cull large amounts of objects. There are a number of popular techniques here. Google for binary space partitioning if you want to have a closer look. I may do a follow-up Smoke and Mirrors video on quad trees or octrees. Please let me know in the comments if you would like to see this. The other strategy that often comes up is occlusion culling. Note how I've positioned my player in the corner of one room, and I'm looking in a direction where our frustum encompasses nearly the entire scene. With the current culling strategy of Godot, almost everything will end up getting rendered. Occlusion culling refers to the technique where we attempt to determine which objects are occluded by other objects and thus do not need to be rendered. In my scene, almost everything is occluded by the walls of the room I'm currently in, so this seems like an excellent option. However, occlusion culling can be fairly expensive, as it often involves rendering the entire scene in a simplified manner just to detect which objects are occluded. A popular method of optimizing this is by selecting which objects are occluders and which objects can be occluded. Without these techniques currently implemented, we need to look at alternatives we can create with the tools that are available to us. Let's look at one possible solution that works well in a closed environment like we're seeing on screen here. There are many ways to implement what I'm doing here, but I went for something that was simple to do in Godot with only a few lines of code. If we only show rooms the player could potentially see and hide any room the player can't possibly see, we suddenly minimize what Godot needs to evaluate by a huge amount, especially as our level starts growing. Luckily, Godot has a built-in mechanism for reacting on a player's location. We can simply set up areas and our physics engine will quickly tell us when our player enters an area and when the player leaves. We simply show or hide the related room as a result of these actions. Our FPS player has a kinematic body that interacts with the areas. I've created a template scene called Room in which we find a few placeholder spatials and an area physics node. Note that the physics node has a mask so it only reacts to the physics layer in which I've placed my player, not to the layers that contain other objects. We add collision shapes in inherited scenes. The body entered and body exited signals are linked up to the script on this room. When we examine the script, we see that we check in our ready function whether we should show or hide the room depending on whether the player is already in the room. Then we either hide or show the room on our signals. When we examine one of our actual rooms, we see the collision shapes defined under our area node. As long as our player is within one of these shapes, the room will be visible. As these are all simple boxes, the physics engine has little difficulty determining if our player is inside. And here's our end result. I've added a little viewport with a top-down camera so you can see the rooms being shown and hidden as our player moves around. Obviously, this technique in its current form only works for specific types of games, but seeing how little work it takes to implement, it's a lot of bang for buck. There is plenty of room for a further optimization. We could limit the collision shapes to the room itself, and keep a table of which other rooms are visible when we are within a given room. Combine this with the visibility change signal, and we could hide rooms that are to the back of us. The technique can be adopted for many other things. In an open world game, you could put an area around a building so the interior of the building is hidden when the player is outside of that area and shown when the player is about to enter the building. That's enough for today. If you found this information useful, please consider giving this video a like. Please also consider following me on Twitter, where I give regular updates on things I'm working on. Until next time.